Struggling with GATE computer science? Find out the secrets to crack it from the toppers.
Ravi sir was the one who crafted my success. His strategy of teaching concepts from scratch made my understanding so strong that I could conquer any question.
Ravi sir motivated me every day to keep going and keep learning. It is because of him that I overcame all obstacles in this journey.
I remember him saying, CS stands for common sense, and that one line completely changed my approach towards the subject.
Being a working professional, I didn't have to spend additional time figuring out what to study. Just watching Ravi sir's videos fully equipped me to crack the exam. The secret
To my success
In GATE is
Ravindrababu Ravula,
sir.
Many success stories, many more waiting to happen. Learn live from Ravindrababu Ravula, only on Unacademy.
Okay. Hello everyone. So we were doing C++ STL, and in C++ STL we were doing generic algorithms. Okay, algorithms which use the support of iterators, or in general random access iterators or pointers, and they can do some functionality. Okay, so you can apply those functions, generic algorithms, to any container. Okay, any container of the standard template library. So we were doing that, and we have seen the sort and the stable sort algorithm. Okay, we have not seen sort heap, so I will remove that from the name of that lecture. So after we cover heap, we can see sort heap as well. Okay, it does not do anything else. If the initial container is a heap, then you can sort a heap using sort heap. Okay, so if your container is heap, so specifically for heaps, they have created another algorithm which is called sort heap. Okay, so after finishing heaps, we will see sort heap as well. For now, you just have to focus on sort and stable sort. So we'll have demo sessions for these as well if you want. So in the Telegram group or in the chat box, just let me know if you want demo also for these functions. So I'll take some containers, I'll take vector of pair and so on, and then we will sort that. Okay, cool. So this is about sort and stable sort. We have done this. And in this lecture, we are going to start with binary search, upper bound and lower bound. So these are also very important algorithms coming to standard template library, because they give directly the functionality of binary search. Okay, and what binary search does is, we have not covered binary search in algorithms. It is not required. We don't require the details of binary search. We are just seeing the algorithms. Okay, that how to apply the function in a standard template library. We are just seeing the syntax and how to apply that. Okay, the actual implementation of a sorting, of a searching and sorting. Okay, we will see all types of sorting and all types of searching, binary search and other types of searching as well, and we will see all types of sorting algorithms as well in algorithms. There you'll know the actual time complexity and everything. Okay, the matrix, the space matrix and the time matrix what are taken, and how do you measure time of a program, and what is the time complexity of different searching algorithms, and what is the time complexity of different sorting algorithms. We will see it there in algorithms, but here we are just seeing the standard template library implementation. Okay, that if you want to write a program in C++, so yeah, how you can use that already written function, already written standard template library function to do sorting or searching or to do various other things. Okay, so after doing the algorithms, this will be more clear. Okay, so you can again come back to these lectures if you want. So let's start with searching. Yeah, Pooja will do that. Okay, we'll take various containers. Okay, vector of triplets, vector of vectors, vector of pairs, and we will sort them. We will do a demo session on it. Okay, so before doing that, actually we should finish pair. Okay, we will finish the pair container, then we will do that. Okay, so things will be more clear. Okay, so if you want to create tuples basically, okay, which means tuples of size 2, pairs or triplets, or even quadruples, okay, of size 4. If you want to create anything of fixed size, then you can use the pair. Okay, so yeah, we will see after pair finishes, things will be more clear. Okay, because when we create vector of pairs or vector of vectors, to sort them we have to write the comparator functions. So we will do the demo sessions for it. Okay, so let's start with the binary search. Meanwhile, you can ask the any doubts if you have. So I'm waiting for 1 minute for more people to join, then we'll start this. Okay. Cool. So let's start with binary searching. Okay. So if you have not joined this Telegram group, I'll give all the updates. So right now we have rescheduled the next 2 lectures. That too has been posted in this Telegram group. Okay. So if you don't want to miss any update, just join this Telegram group. Okay. And all the demo lectures, whatever code I write, I'll be sharing that in Telegram group. And for the slides, I'm figuring out a way. So if we cannot post them on Unacademy app, I'll post them on Telegram group. Okay. So just join the Telegram group for all the updates. Cool. So before that, a new batch is going to launch on 23rd. So if you have your placement sessions coming up in next 4 months or 6 months, so in just 4 months, the target is to make you solid for the placement drives. Okay. So all the data structures and algorithms. So those who are in a hurry and in 4 months, they want to learn everything that is required just for placements. Okay. So not very detailed I mean, data structures or advanced data structures and algorithm will be covered in this course. Everything that is required to get you placed in good product based companies, everything that will be covered. Okay, and interview experiences and all of that will be shared also. So if you want to join this batch, you can take the 6-month subscription as well. Okay, you will be able to watch all the entire batch. And if you take the 1-year subscription, you'll have access to the batches that will take 1 year, and you'll have the access of this batch also. If you take the 1-year subscription, in 1 year you'll have access to all the batches that launch. Okay, so you can watch the lectures and placement batch and other batches as well. So we'll discuss about that in the end of the slides. So yeah, let's start with binary search. Cool. So if you don't know what binary search is, so in a sorted array, I'll just give you okay, I'll just give a quick explanation. We don't require all the details of how it takes log n time, how it searches efficiently. We don't require the exact implementation details. We will discuss that in algorithms. But in a sorted array or in a sorted series of elements, a sorted vector, okay, if you want to search for a particular element, that you want to find that 21 is present there or not, okay, so you need not search that one by one, that this is 21, this is 21, this is 21 or not, this is 21 or not. You don't need to do this. Actually, in a sorted array or a sorted vector, you can search for any element in log n time. Okay, if there are n elements, in just log n comparisons, you can search for an element. Okay, this is what binary search says. Okay, it is very simple algorithm. We will see that in binary search. But now you know the target. When we speak about binary search or upper bound and lower bound, what do we want? We have a sorted container. We already have a sorted container, a sorted array or a sorted vector. We want to search for one particular element, and we want to do this search super fast. Okay, so actually the difference between n and log n is huge, right? The difference between n and log n is very huge. It doesn't look like that, but log n is very small as compared to n. Okay, so actually binary search is very fast as compared to the linear search. So if you want the searching to be very fast, and if your array is already sorted or your vector is already sorted, this might be the case in many competitive programming problems, okay, that you already have a sorted vector and you want to do many searching queries to it. Okay, many times you want to search some element. So what happens is you first sort it and then you can apply binary search. Okay, so every search will be very fast. So yeah, this is the concept of binary search. So since we have seen sorting and stable sort, so if you are watching this lecture before sorting, I will suggest that you watch the lecture of sorting first. Okay, so because the templates written, the syntaxes here exactly match with the sorting syntaxes. Okay, so we have seen in detail that what this syntax means, what is this return type, what are these iterators and everything, right? So binary search works for any container that supports forward iterator. You don't require a random access iterator. It works for forward iterator as well. Okay, so it will work for list also. Okay, list has bidirectional iterators, so it has forward iterators, so it will work for lists as well. Okay, so you just want a forward iterator, you need to pass two forward iterators. You just need to pass two forward iterators, and the third argument is the value. I have told you 2 times that what this const means, what this and means. If you know this thing, just write in the chat box that why we have this const here and why we have this and here. Okay, this is clear. Okay, so we have to pass two iterators both of the same type. We have to pass two iterators both of same type, and the third argument is a value. Okay, and it can be of different type. Okay, so in this template we have two types. Let's say this is T1 and this is T2. Okay, so the first and second argument should be of same type. They should be of type iterator, and the third argument is of type different type. Okay, yeah, very correct. So this AND is used to avoid the copying of large containers. Okay, so in constant amount of time when you want to pass something, then we have to pass it by reference. Okay, so that's why we have this AND, and this const says that you cannot change its value. Okay, in this function, so that's why we have const and AND here. So that is how you look at a particular syntax. In the binary search function contains 3 arguments, 2 iterators and a value. So it will search for the value between these 2 iterators, but the condition for binary search is everything between these 2 iterators should be already sorted. Okay, should be already sorted, otherwise it might not end. Okay, it might be the case that it is never ending, so you might get different types of errors. So you might get error or different type, you might get different types of exceptions. Okay, the condition is that this particular range should be already sorted. This function will not check that the range is sorted or not. You have to make sure. Okay, why? Because this function is supposed to take log n time, right? And just to check that this particular range is sorted or not, it will require n time comparing all the elements, right? So it will not check for you that the range is already sorted or not and raise an exception. It will not do that. Okay, it will just run the binary search algorithm on the unsorted container if you have not passed a sorted container, and you will get different answers. Okay, so it might end or it might not end. That is the case with binary search. Okay, so it will not check that the container is already sorted or not. You have to make sure that this particular range is already sorted, then only this algorithm will work. Cool. So it also has two syntaxes. First one is this, very easy. We have two iterators, it1 and so first and last, and one value. So it will search for this value well in this range. And the second is also very easy. If you have seen the sort lecture, it is also very easy. It has 4 arguments. The first iterator, the second iterator, the value, and the comparator. Okay, the fourth argument is the comparator. So you can search for an element in a vector which is sorted in descending order as well. Okay, you just have to pass the same comparator function here as well. You have to pass the comparator function which was used to sort this particular vector. Okay, so you have a container, you have sorted it using some comparator comp. Okay, you have sorted it using some comparator comp. You have not used the default sorting mechanism. You have created your own comparator for different types of vectors, and you have used that, okay, to sort this. So if you want to search for something, if you want to apply binary search to it, then you have to pass that particular comparator to binary search as well, okay, so that it knows that this particular comparator was used to sort this container. Cool, so very easy. So binary search actually just returns a boolean value that a particular element is present or not, true or false. So if you want the position as well, that where this element is present, then you have to use upper bound and lower bound, that we will see later. So that's the difference, okay. We have 3 functions. Binary search, if you just want to check that a particular value is present or not in very short amount of time, okay, then you will use binary search. And if you want to know the position, that this element is present where, okay, that also can be done in log n time only, but for that you have to use lower bound or upper bound functions, okay. So what does binary search do? It tests if the value exists in the sorted sequence or not, okay, simple. And so what it will do, it returns true if any element in the range first to last, okay, last here is not included, here also last is not included. You are passing 2 iterators, but the last iterator is not included. So you can use binary search with an array like a plus n. So you are passing 2 pointers, or you can use it with vectors v dot begin, v dot end, okay. So this element will not be included, okay, and then you can pass the value which you are searching for. Cool. So it will return true if any element in the range first to last is equivalent to well, and return false otherwise, okay, very simple. So the elements are compared using the operator less than for the first version, okay, this is the same thing. So actually binary search also requires comparison, just as sorting, binary search will also requires comparison. If the current value is less than, then it will go to left side. If the current value is less than so what happens is, you have a vector, it will search for it will compare it with the middle value, okay. If the middle value is greater than what you are searching for, it will search left side, and if the middle value is less than what you are searching for, it will search right side, okay, and so on. It goes like this. So it requires comparison, okay. So for this comparison, if you are using the first syntax, the less than operator will be used, and if you are using the second syntax, the comparator function which you are passing will be used, okay, comp for the second. Cool. So this is the most important thing when you are using binary search or upper bound or lower bound. The elements in this range shall already be sorted according to the same criteria, okay. So it should be sorted using the same criteria which you are using for binary search. So in the binary search, if you are using the first syntax, so automatically less than is used, okay. So the initial sequence should be sorted using less than only. And if you are using some comparator function for binary search, then the initial sequence should be sorted using that particular comparator function only, okay. So you have to pass that comparator function also. Or if it is not sorted, it should be at least partitioned, okay. So this thing actually sorting is not really required, it should be at least partitioned. So if you don't understand this thing, you can skip this right now. So this will be more clear after we learn quick sort, okay. In quick sort we have to partition the array. So right now I am not covering that. If you already know quick sort, then you must have understand this thing, okay. We'll cover this thing in quick sort. So either it should be sorted or it should be at least partitioned according to that that particular value well. Okay. So Jaideep, we have puzzles tomorrow. We'll have 2 more puzzles tomorrow. So this is our binary search function, and it has 2 parameters, first and last. So first and last should be forward iterators to the initial and the final position of the sorted or properly partitioned sequence. Okay, you can skip this properly partitioned thing for now. So it should be initially the sequence should be sorted. You can think of it this way, and you have to pass the initial and the final position of the iterators. Okay, you have to pass 2 iterators, and it will search everything between these 2 iterators, including first iterator and not including the last iterator. Cool. So the range used is first and last, which contains all the elements between first and last, including the, okay, this is easy. Okay, and second argument and the third argument is the value to be searched in the range, and the fourth argument, if required, it is only required in the second syntax. So you have to pass the same comparator function. Okay, so this is an example of binary search. So here we have the integer array. We have created vector of it. We have seen this thing in previous lecture. You can create an vector using an array. Okay, you just have to pass the pointers. Cool. So this vector will look like this. Okay, now we have sorted it using the sort function, v.begin, v.end. So we have sorted it. So now we will look like this: 1 2 3 4 5 6 7 8. Now we are using the binary search function. Binary search, v.begin, the first iterator, we have to search from v.begin to v.end. So everything, we have to search the entire vector. This is what these 2 iterators are saying, and we have to search for the value 3. Okay, so if the search is successful, if 3 is found in this vector, this particular thing will be run. So found will be printed here. Okay, so since 3 is present in this vector, found will be printed. So this is this easy. You can have any container, you have to search some element in it, and you can use binary search for that. Okay, and it will do that in log n time. Okay, the most efficient search will be applied. And here is an example using the comparator function, the same comparator function which we used for sorting, the fun function. Okay, so this will sort the vector in decreasing order. So after sorting using the fun function, the vector will look like this. Okay, and here also you can use the same binary search. Okay, so here is an error. Here you have to write fun as well. Okay, so here is an error. I will correct it. You have to use the fun function as well. Okay, you should have 4 arguments: v.begin, v.end, the range which you want to search. The third argument is the value which you want to search, and the fourth argument is the comparator function which was used for sorting. Cool. So yeah, here also, so this will also take log n time. Okay, so these functions will be very useful. Okay, going forward, binary search, sort, we will be using them very extensively. Okay, there I will not be explaining that how this is working. So that's why we are seeing that here. And the next function is upper bound. Definitely, Shubham, definitely you have to know that how binary search is implemented. Okay, in an interview he might stop you from using binary search function which is already present. He will say that just write the binary search in front of me. Okay, that your question can be this, that you just have to write the function binary search. Okay, then you cannot use this binary search. Okay, if some interviewer is asking you to write the code for binary search, don't write this function, right? You have to implement binary search there, and that we will see in algorithms, that how binary search works, how you can write code for it. But in actually in competitive programming and in coding rounds, no one is going to see your code. Okay, and it is good to use a standard template library. Okay, you have to save time. People have already implemented this thing. Even in industries, when we are writing code, it is allowed to use API. Okay, so you can use APIs. You don't have to write the same code again, and actually they are written in very good manner. You cannot write the same code again. Okay, you will make some mistakes. So they are well tested algorithms and they are written very efficiently. Okay, you cannot match those algorithms which are already written. But in interviews, someone might force you to write the sorting algorithm, one particular sorting algorithm. Okay, then you cannot use the sort function. So you must know how the sort function is implemented and how binary search is implemented. That we will see in algorithms. Okay. So Ali, I have not yet joined. I'll join in July. Okay, I'll join Google in July. Yeah, so Pukhraj, you can use STL in interview. That is a very good question. Okay, you can use STL in interview. Most of the companies will not stop you. Okay, so in Google, Microsoft, I am very sure I have given those interviews. They will not stop you to use STLs. Okay, so even if the interviewer doesn't know this particular function, he will ask you that what this function does. So in the comment you might have to write that this particular function does this thing and takes this much amount of time. Okay, so even in Google interview I was given a question about priority queues and heaps, and I used priority queue container and I used all the algorithms present in it. Okay, you have to save time there. Okay, you cannot implement everything. So many companies will not stop you doing that, but if the interviewer is saying that you have to implement this particular thing, you must know, okay, how this works, how heap works, how binary search works, how sorting works. You can start writing STL, you can use STL, the interviewer will stop you. Okay, if you want some specific implementation, he will stop you. Okay, so next is upper bound. So the syntax for upper bound is exactly same as binary search. Okay, same two syntaxes, two iterators and the value, two iterators, the value and the comparator function, exactly same. The only difference is here we will get the position also. Okay, we will get the position of the upper bound of a value. Okay, what upper bound is, what lower bound is, we will see. But what upper bound function will do, it will return the position of the upper bound of that particular value well. Okay, that which we are passing. So what is upper bound? Yeah, so in this vector, if we are searching for 3, in this vector if we are searching for 3, we will give, it will return an iterator to this position. Okay, a value greater than it, that is called the upper bound. Okay, any value greater than the value which you are searching for, it should not be equal, strictly greater than. Okay, this is called the upper bound. So it returns the iterator to the upper bound. It returns an iterator pointing to the first element in the range, first to last. Last is not included. Okay, this is the range, first to last. It will search the value well in this range, in this iterator range, and it will return an iterator only. Okay, this function takes two iterators and returns an iterator only. Fine. So it will return an iterator pointing to the first element in this range which is greater than well. Okay, strictly greater than well. This is what upper bound is. So the elements are compared using the operator less than. So everything else is same as binary search. Okay, if you are using the second syntax, you have to pass the comparator function. If you are not using the second syntax, you just have 3 arguments, the first iterator, the second iterator and the value which you are searching for. Okay, and this function will return an iterator pointing to the element which is strictly greater than the first element, which is strictly greater than well. Okay, so you just have to remember this thing, first element strictly greater than well. Okay, the well is our third argument. Cool, and it will return an iterator to it. Okay, this is what upper bound does, and it is very surprising that some problems will strictly require upper bound. Okay, what happens is, these are all the tools, we are gathering tools and we will go for hunting now. So we don't know what tool we will require in hunting. Okay, so depending on the environment, depending on the situation, depending on the problem, we will require different tools. And so we are preparing our toolbox by seeing these generic algorithms, iterators, containers. Okay, we in any particular problem, any container, and in container also any algorithm can be required. Okay, so many times you will be required to calculate a upper bound in a program. Okay, so you will not think about it that how many times you are using upper bound, but you will be using it extensively. Okay, that I can guarantee, lower bound and upper bound. So in many programs, in one program also you might have to calculate the lower bound and upper bound for any integer on a vector many times. Okay, so yeah. Yeah, Hitesh, correct. So I am coming to that. So I was going to come to that. If the value is not present, it will return v dot end. Okay, the last pointer to the element which is after the last value. Okay, v dot end. If you are passing pointers to arrays, it will return a plus n. Okay, so whatever the last iterator you are passing that is not included in the search, this iterator will be returned if the value is not present. Cool. The fourth point here is same as in binary search. The elements in the range should already be sorted according to the same criteria. If you are using the first syntax, they should be sorted using the first syntax in the sort function. If they are sorted using some comparator function, you have to pass the same comparator function in upper bound also. Okay. So the parameters are first and last. They are easy now. You know they are forward iterators, and the val and the comparator function. Okay, 4 parameters at maximum. So the return value here this is mentioned. So the iterator to the upper bound position for a value in the range will be returned if no element in the range compares greater than the value. If no element is greater than the value. Okay. So there might be two cases. Okay. If all the elements are greater than the value, then v dot begin will be returned. Okay, because the first element is actually the first element which is greater than val. Okay. So if this is our vector and we are using upper bound to this vector to find 2. Okay, so what is the upper bound of 2 in this vector? It is 3, right? The first element is actually the first element which is strictly greater than the value which we are searching for. So here v dot begin will be returned. And if we are using upper bound in this vector to search, let's say 5. Okay, so there is no upper bound to 5 in this vector. There is no upper bound to 5 in this vector. Okay, there is no element which is greater than 5 in this vector. So v dot end will be returned. Okay, this is how it works. Cool. So here is an example of upper bound. We are trying to search 2. So what will be printed here? Okay, I'll not tell you anything. You just have to see the code. Just remember that upper bound returns an iterator. Okay, and since vector contains random access iterator, you can do arithmetic. Okay, you can subtract 2 iterators. So what will be printed here? Just write in the chat box. What will be printed here? Dheeraj, how does it work? We will see in binary search. Okay, it uses binary search. Very simple. If you know binary search, you can solve this problem also. Okay, you can solve the problem of upper bound and lower bound. You can create lower bound and upper bound functions using binary search only. Okay, they are little bit modified versions of binary search only. So when we see binary search algorithm, after binary search algorithm, we will write codes and there we will implement all the 3 algorithms: binary search, upper bound and lower bound. Okay, now for now you don't need to worry about it. Okay guys, we have got 2 2s and 2 3s. What do you think? What is the upper bound for 2 here? Okay. So this position is the upper bound for 2, okay? So the iterator to this position will be returned, and this is the iterator to v dot begin. and what is the difference between them? It is 2, right? This is v dot begin, this is v dot begin plus 1, and this is v dot begin plus 2. So it is like subtracting v dot begin plus 2 minus v dot begin, right? So it will be 2. Okay, this is v dot begin, this is v dot begin plus 1, this is v dot begin plus 2. Okay, think of it this way, and an iterator to this position will be returned. So when we subtract them, we will get 2. So the position is 2 also. Okay, when we have 0 indexing, the position is 2. So this is how you can calculate the position of the upper bound using the upper bound function. Remember, it will return an iterator. Okay, don't use direct iterator as a position. Okay, this is the common mistake. You have to subtract v dot begin also to get the value. Okay, this is now an integer. This is the position basically. Okay, you have to subtract v dot begin. Upper bound and lower bound returns iterators. Cool. So lower bound also has the same syntax as upper bound. Both the same syntaxes, same as binary search, same as upper bound. I'll not repeat it again. There is no point in wasting time with that again. So we have 2 iterators and work same as binary search. But here what it will do, as you might think, it will return the iterator to the lower bound of the value. Okay, and what is the lower bound? It is the first position which is less than or equal to that particular value well. Okay, first position, iterator to, it returns iterator to first position less than or equal to well. Well is our third argument. Okay, it returns an iterator pointing to the first element in the range first to last. So the range is first to last, last is not included, which does not compare less than well. Okay, sorry, it should be greater than or equal to. Okay, it should be greater okay, which does not compare less than well. Yeah, it is definitely not less than or equal to. It should be greater than or equal to. Okay, first position greater than or equal to, right? The first position less than or equal to will always be the first element only. Okay, so this statement is more correct. It should not be less than well. Okay, we have to find the first position which is not less than well. So what is it? It is either greater than or equal to well. Okay, so I'm sorry for this. The first position greater than or equal to the value well. If we write less than there, it will always be the first element, right? You can think of it that way. So it should not be less than well. Okay, so it can be equal also. So when we find the upper bound, the value should be strictly greater. Okay, it should not be equal. So actually the lower bound and upper bound can be same if the value is not present. Okay, think of an example where upper bound and lower bound are same. Okay, you can find some examples. The elements are compared using the operator less than, and yeah, the other things are same. The sequence which you are using to find the lower bound should be already sorted, and the sorting algorithm should be same. If you are using the first syntax, you have to use the first syntax for sorting. If you are using the second syntax, you have to pass the same comparator function as the fourth argument in lower bound. Okay, so the arguments are same, first and last, well and comparator. So here is a beautiful example. Just let me know both the values. Okay, here I will not tell you what the answer is. I'll give you 2 minutes to think. So if you cannot see this, we are searching for 2. Okay, we are trying to find the lower bound and upper bound of the number 2 in this vector. Okay, in this vector we want to find the lower bound and upper bound of the number 2, and what is the position for that. Okay, Gautam, I'll see your message. Okay, it is very difficult to see all the chats in Telegram. Okay, personal messages. I'll do that. So no, if you have the vector 1 2 3 4 5 6, then the upper bound of the element 6 will be v dot end. Okay, because there is no element greater than 6. HM classic. 6 is not no element is strictly greater than 6. Okay, so that's why v dot end will be returned. Okay guys, just let me know what will be the values. What will be low minus v dot begin and what will be up minus v dot begin. Okay, you just this is wrong. Okay, you don't have to look at this. This is our vector v. Okay, congratulations, Durgesh. Cool. So some of you are writing 2.6, some of you are writing 3.6. So what is lower bound mean? The value should not be less than. Okay, the first element which is not less than well. The first element which is not less than well. Is 1 less than 2? Yes. Is 1 less than 2? Yes. Is 1 less than 2? Yes. Is 2 less than 2? No. So yeah, this is the lower bound for 2. Okay. So it can be greater than or equal to. It can be greater than or equal to. So here 2 is equal to. So this is what lower bound will return. Fine. And what position is this? 0, 1, 2, 3. So the first value will be 3. Okay. This is v dot begin. This is v dot begin plus 1, 1 plus 2 plus 3. So 3 is the so position number 3 is the lower bound. And what is the upper bound? It is the value which is strictly greater than. Okay. So this is the position which is strictly greater than well. And what position is this? Okay, 6th position. So it will be 6. Cool. It was a simple question. So actually these values will be useful later. No one is going to ask you questions like these, okay, but they are useful for your competitive programming skills. Okay, we will see. We will be using lower bound, upper bound. Okay, and similar functions are present in Java and Python as well. Okay, so actually you need to know the meaning of lower bound, upper bound. Similar functions are present in other languages as well, and you can code in any language, but the basics will remain the same. Okay. So yeah, we will be using these. If you have any queries, you can ask me, or we'll meet in the next lecture. So this is the Telegram group. If you have not joined yet, let's discuss about the placement batches, and you can ask me doubts as well. Okay, I'll be answering your doubts. So in 4 months, the target is to master data structures and algorithms which are required for placements, and it is going to go live from 23rd March. So you have 4-5 days to make a decision. And actually the difference between 6 month and 1 year subscription is not too much. Okay, only 4,000-5,000 difference is there. So you can go for 1 year subscription as well. Then you'll be able to watch this placement batch, and along with that you can join some detailed batch as well. Okay, for competitive programming. So your placements will be done, and placement preparation will be done, and your competitive programming preparation will also be done for contests. Okay, so you can join both vertex and placement. You just need to buy one subscription. You'll have access to all the batches. Okay. So this is the batch structure from basic data structures, advanced data structures, string algorithms. So the things will be a bit faster here. Okay. So in just 4 months, all the generic algorithms which are asked, many practice problems will be solved. And yeah, see, so this is the entire syllabus. Okay, DP and graph, these are the most important topics. So entire 1.5 month will be dedicated to these two topics only. Okay, so plenty of problems will be solved basically. So previous interview problems will also be solved in the last 1 month. So these are the educators who are teaching. They are ACM ICPC world finalists and they have experience of interviews basically. Okay, placement interviews. They have been software engineer in Google, Facebook, LinkedIn, Flipkart. Okay, so yeah, we have plenty of experience in Unacademy's interview preparation and competitive programming team, and these are the educators who will be teaching. And we have the other session, we have other sessions for STL as well. So on this YouTube channel only at 9:30 we will start the next session. Okay, if you're watching me for the first time, I'm Bansal. I got All India second rank in GATE Computer Science 2019 and All India 39th rank in ACM ICPC 2019. And recently I got placed in Google. I'll be joining Google as software developer. Okay, and I'll be teaching CP, C++, data structures, algorithm and interview preparation on this YouTube channel as well as on Unacademy. Okay, so I'll be teaching some batch as well very soon. So you can take the Unacademy subscription and watch me there. So even if you don't want to watch the take the subscription, you can just go to the Unacademy website and watch the special classes. Okay, for all the educators, me, Ravi sir, any educator, there are special classes. They are for free and you can watch the special classes. And if you want to activate the special classes, it will ask for a code. They are free but it asks for a code. Okay, just write the code JAYCP and you'll be able to access it. Or if you want to purchase the subscription, the 6-month price is 24,300 and 12 month is 29,700. Okay, and if this is the price after you use the code JAYCP. Otherwise so this code basically gives you a 10% discount. Okay, it will be 33,000 if you don't use the code. So let's meet at 9:30 PM and we'll see more functions in standard template library. Okay, bye.